Hi, everyone. I'm Muneeb, co-founder and CEO of Blockstack, and today I'm going to basically walk you through the state of decentralized applications and walk you through how we approach it and what's our architecture. I'm a computer scientist at heart, so it pains me to start presentations this way. We do have public filing with the SEC. We took a slightly different approach where we decided to work with the US regulators in terms of opening up the US markets on our network. And we have done a public filing with the SEC. The disclaimer here basically says that even though this presentation can be considered testing the waters, this is purely a technical talk. I'm not trying to sell anything to anyone right now. And if there is ever an offering, you should look at the actual offering material for that. And there might be some forward-looking statements in my presentation as well. With that said, at a very high level, what we are noticing here is a completely new computing model, right? So you can broadly divide this into, we had mainframes, we had desktops, and then we got cloud computing. And at each stage, there was some key resource. For example, IBM was very focused on the hardware, didn't care about software. And when desktops came and everyone got their own computer, it became a lot about the software layer. And the desktop applications were written very differently from mainframe applications. And then again, the model flipped, and people started writing cloud applications. Google versus Microsoft can be viewed as Microsoft basically monetized operating systems and the software licenses around it, whereas Google has never charged you for a software license because they monetize user data. The Googles and the Facebooks of the world, they're sitting on large amounts of user data, and that's their business model, where basically they're in the business of knowing more and more about you. And the ray of hope that we see with decentralized computing is where users can actually have their own private data lockers, their own private information, and the applications, they start resembling desktop applications. You download the applications, they run locally, and there's no big company in the middle. All of that sounds very exciting, but if you look at our industry right now, it looks like that we have been trying to implement it in a somewhat of an odd way called the world computer. First of all, I'm not trying to reference any particular project. The world computer at this point is more of a design philosophy where people are trying to build blockchains where they're trying to do everything at the blockchain layer. Right? And this is actually the vast majority of projects in the space right now. So I just want to make this abundantly clear that I'm not trying to target any of these comments at any single project. This is more of a technical discussion. So first of all, if you're excited about Web3, we should understand that Web3 does not equal the world computer. The world computer is one proposal for how Web3 decentralized applications can be implemented. In fact, you don't even need blockchains to design decentralized applications at all. Before I started working on Blockstack, I was actually doing research work on more secure internet infrastructure, where we had alternative designs where you could build decentralized applications without even using blockchains. Blockchains just make it easier to do it if used in the appropriate way. So I think in our minds, we should first separate out the concept of decentralized apps and Web3 and the concept of a world computer. They're not the same thing. And secondly, we should look into what this world computer idea is, what is it good for, and what it's not good for. So there were two main ideas that were introduced with this philosophy of a world computer. One is global state, which means that every node, every user on the network basically keeps a copy of the global state. And every time there's a state change, every single node on the network has to process that state change. It works well for certain applications. For example, in decentralized finance, it makes sense that that state is not a lot. And if there has been a transaction that other people need to know about it, they also need to process it and kind of like do that state change. The second idea was this idea of like Turing-complete languages and writing smart contracts in Turing-complete languages. I think that there is room for improvement there. We are in the camp that Turing completeness is not required. You basically should try to focus on the security of the application, the predictability of it, and formal verification of these smart contracts. But in general, I think smart contracts make sense if you're talking about decentralized finance applications, because you need some logic and you need to automate it at the blockchain layer. If you take these concepts now and you apply them web apps, which is what's happening in our industry right now, they completely break down, right? Because global state is something you absolutely cannot scale to at the blockchain layer. If I'm tweeting and everyone in the world needs to do a global state change because I tweeted, that's almost by definition is the opposite of scalability, because every new user is slowing everybody else down. Right? Every new application is slowing every other application down, and you absolutely cannot design systems that have global state and can scale to the kind of usage that we're used to on the traditional internet. Similarly, smart contracts are a really bad fit for writing Web3 applications. Think of it this way, that programming languages have been around for decades before smart contracts came around, and now we are trying to hammer general purpose programming into the idea of smart contracts. Currently, if you want to build a Twitter on top of these world computer projects, you are forced to write it as a smart contract, which is not the way that you should be designing these systems, right? So very broadly, I think some of these concepts make sense for a subset of applications, but they absolutely don't make sense when it comes to Web3 type general purpose applications. And this is the work that we have been doing. First of all, these are not theoretical things. Our industry is struggling with scalability. Our industry is struggling with security when it comes to these applications, and they can broadly go back to these two concepts, global state and Turing complete languages at the smart contracts layer. So at Blockstack, our approach is extremely different. It's almost like a very different architecture, a very different school of thought. And what we believe is that you don't need to design quote-unquote heavy blockchains. We are trying to put a lot of data, a lot of logic, a lot of processing at the blockchain layer. You keep the blockchain layer as minimal as possible. So you call it quote-unquote light blockchain. And then you focus on designing the rest of the computing stack, and you handle scalability there. So we spend a lot of our time designing a reliable, high-performance, decentralized storage system where people get their own private data lockers, which is meant to be long-term storage. Like imagine that this is your home drive, right? Like people are not going to start saving data on a blockchain or on a peer-to-peer network in the long term. And these things need to scale similar to how cloud storage systems actually scale. So in terms of full stack scalability, we feel like this is where Blockstack shines. And one thing where we have done very differently from other projects as well is in the design of our smart contracts language system. It's not Turing complete. Programs are actually evaluated when you publish them instead of when you run them, right? So even before a node runs a smart contract, you know precisely what the contract can and cannot do. And that's very important for security, because then you can do formal verification on these programs. And another way to think about this is that there's no concept of a gas price for these smart contracts, because you don't have to estimate a gas price. You're estimating because you don't know what the contract is going to do, right? And in our system, you're actually sending very precise amounts of stacks tokens to the contract because you know exactly what the execution path is going to look like even before you run the contract. We actually went to the extent of not even having a compiler for the smart contract language. Because if you do formal analysis on something and then compile it and run what's compiled, what you're running is not the thing you did the formal verification on, right? So in general, the extreme focus is on security and predictability, and that's where our approach really shines as well. So I've gone over most of these points, but the key takeaway needs to be that everything doesn't need to be a smart contract, right? Smart contracts are a very precise tool, and they should be used only when needed. It's not that every programmer in the world is now going to start retooling their existing applications and try to force them to be smart contracts on top of blockchains. So this is the thing that I'm the most excited about. And the fact that there are more than 100 different applications, you can think of them as startups, that have built real apps on top of our platform just in the last 6 months. And the reason why we are seeing this developer traction in the last 6 months is that various pieces of the computing platform started coming together. Examples of applications are all the way from alternatives to Google Docs, alternatives to messaging apps like WhatsApp, or social networks like Facebook, or professional social networks like LinkedIn, to 1Password, DocuSign, and the list just goes on and on and on and on. The analogy would be if Amazon AWS figured out the scalability of cloud computing, and then developers basically started building all sorts of startups on top of it. That's the work we did over the last 5 years. And what we have done is we have made it extremely simple for developers to build applications on top. Most of the developers, they don't need to worry about the complexity of blockchains. They don't need to worry about complexity of decentralized storage systems. They just have libraries that they use. They can work in programming languages that they're already familiar with. They don't have to learn a new programming language or think of like, how do I write this as a smart contract, and very quickly build these applications on top. This is what we do. We provide a full stack alternative to cloud computing. And it's very important to keep in mind that you need every layer of that stack to actually work before developers can build real applications, before developers can deliver real utility to their users. Even if some layer is missing, developers can't really build their applications, right? So you really need a full stack approach. You need authentication, you need storage, you need consensus layer, and so on and so forth. And this is what the developers are doing. Just like they were able to use cloud computing and build all sorts of different applications, we are seeing a very broad category of applications rapidly being developed on top of our platform. So a little bit about the team. The project started at the computer science department at Princeton. This is where I met my co-founder in 2013. And it's very heavy on distributed systems computer scientists. We very explicitly raised venture capital to do R&D work. We were very explicitly in the R&D phase, then started building infrastructure in 2017, and launched our Stacks blockchain in Q4 of last year. And now we're in the developer traction phase where the infrastructure is ready. It actually scales to millions of users and can be used by these developers. This is what the full stack looks like. The critical piece that we are launching this quarter is our smart contract language. There's a simple smart contract language that's already live, but our full-fledged language will be released this quarter. So I won't be able to go over kind of like all different components of the stack. I'm just going to focus on the 3 most important ones. That's authentication, storage, and the Stacks blockchain. In terms of authentication, let me walk you through what it looks like from a user perspective and what it looks like from a developer perspective. So from a user perspective, instead of signing up on new websites or applications where you get a new username and you need a new password, or instead of depending on services like Facebook Connect or Google Auth, you basically register your own username. So that's a universal ID that you get, and you directly own it with a private key. And after that, logging into an application is just a single click. By the way, all of this is live, right? So you can download Blockstack, you can see all of these 100 applications built, you can try them out, and there's no difference between signing up or logging back in, because there are no passwords, there's no new accounts you need to create, it's your own universal ID that works everywhere. And these applications will automatically pull any data like your profile picture or something else that you are willing to share publicly. On the developer side, instead of running servers and worrying about databases, you basically just drop in a developer library, and it's a replacement for something like Facebook Connect or Google Authentication. But more importantly, you're not dependent on a company like Facebook or Google at all. It's a fully decentralized authentication system. So I think this system is a win both for the consumers, because it's more secure, it's easier, it reduces the friction for trying out new applications, and more importantly, it's a win for developers where they don't have to rely on any large companies and don't have to be held liable for any user data that leaks from their databases. They even don't have to pay bills for running these servers and databases. On the storage system side, this is where we did a lot of work. And I feel that I need to differentiate this work from some of the stuff that we've been noticing in this industry. Our storage system is not a peer-to-peer based storage system. Peer-to-peer systems have been around for decades. I actually did research work in that particular area between 2003 and 2008. They're very well-studied phenomena, and we know the limitations of peer-to-peer systems. Most of the projects these days, they use a protocol called Kademlia, which is from 2000, 2001. And it's a very well-studied protocol, and we know what the downsides are. Peer-to-peer systems don't compare to traditional cloud storage when it comes to scalability, reliability, and performance. They tend to work at small scale and always tend to break at large scale. So when we were designing our storage system, a key design requirement was this needs to work as good as cloud computing. And we ended up designing a wide area file system that is repurposing a lot of the cloud storage capabilities that we already have in a decentralized way. So every user gets their own private encrypted data drive that they can place anywhere you want. So think of this as we are reducing cloud providers to dumb hard drives. And everyone is putting like an encrypted data blob wherever they like. It could be Google, it could be Dropbox, it could be a Linux server that you like, it could be your laptop. And our wide area file system would basically, you can mount it and you can start saving data there. And this is radically, radically different from any of the storage approaches that you might have seen in the crypto industry in general. Because you can do a head-to-head comparison with something like Amazon S3 and get 98 to 99% performance because you're only paying the overhead of encryption, decryption. Underneath, you're kind of like reusing the same pipes, you're reusing the same infrastructure, you're just making sure that this is now decentralized instead of centralized. So on the Stacks blockchain, that's kind of like our foundational building block. Because no company is the gatekeeper for our network, there is a token called the Stacks token that is required to kind of access the network. If you want to register a digital asset like a username, or if you want to publish an application, or if you want to publish a smart contract, you require this token. Similarly, the token is also used if you want to execute smart contracts. Remember when I said that you know precisely how many tokens to send to a contract because you know exactly what the contract would do? This is where the token is used. It's used for compute. We also look at the Stacks token as kind of like a share incentive mechanism. And most projects, they have incentive mechanisms for core developers, like myself or other team members at Blockstack. What we have done is that we have broadened that definition, and we look at tokens as an incentive for developers in general. So we have this app mining program where depending on the quality of your application, there's a token distribution that goes out to developers. And we've been running that in a pilot phase for the last 5 months, and it's been very successful. We have a lot of data on this. We have fine-tuned the program a lot and work with game theorists from Princeton and NYU to design it. Think of this as an automated way of generating something like an app store, but there's no company that is picking the winners, right? There's game theory involved in it in the sense that you want a mechanism where it's very hard for participants to game the system, yet at the same time you want them to compete on the right metrics. So for example, we added a reviewer that was reviewing these applications on the usability of apps because usability was very low initially for these applications, so we wanted them to improve their UX. So we are incentivizing that, but by reviewing them on the right metrics, and we notice a change when we get the right incentives in place. For the last couple of months, this has been running in a pilot phase. Only $100,000 of value is flowing through this system per month, And with our public filing, you can see that this number will go up to 1 million a month once our public filing is qualified by the SEC. At that time, there are real incentives for developers in place where if they can build a high-quality application, this could serve as an on-ramp for them for building a sustainable business for themselves, or even like raising venture capital or other sources of funding on top. So in general, our project was heads down on engineering and core R&D for a very long time, and now we're at a phase where we have started focusing on app growth and broadly developer education. One thing I would like to point out is that our crypto industry is still extremely small. There isn't a lot of point like trying to compete with each other because the blue ocean of developers is by far outside of our industry, and that's where we focus on. Most of our developer distribution channels are outside of crypto, and a lot of developers who are sometimes even skeptical of blockchains become interested in this platform, and they look at this as like, I don't even need a backend for my system. It's just easier, cheaper, faster for me to build my app in a decentralized way instead of building it on top of cloud computing. I do believe that this notion of a world computer kind of misled our industry in a way where we ended up building applications that were fundamentally not scalable or fundamentally not secure. And I think we kind of like need to unlearn that model a little bit and approach Web3 as something that is very different from a world computer. And in fact, it's the exact opposite of a world computer. Thank you so much.